Hello everyone, I'm Hw4 and I'll be explaining you guys the solving of the second question of homework 4 in the course Probability and Stochastic Processes. So let's have a look at the question. The random variable x is a uniform in the interval -1 to 1. We're supposed to find g of x such that if y is equal to g of x, then the probability distribution function, that is f of y is equal to e power of minus y into u of y. Now let's look at the solving for this question. It is given that x is a uniform function in -1 to 1. We are supposed to prove that y is equal to g of x, which is equal to e power minus y into u of y. And f of y, which is the probability distribution function, is equal to e power minus y into u of y. We're supposed to prove these two. Now, since it is given that x is a uniform in the range -1 to 1, then the area under this graph will be equal to 1. That is, the area of this will be 1. Now, we know x is between -1 to 1 and the area of this graph is equal to 1. Therefore, the height of this graph will be 1 by 2. Therefore, the probability distribution function graph will be as shown below. Now, we will calculate the cumulative distribution function from the probability distribution function by taking the integral from -infinity to infinity. Therefore, the cumulative distribution function is equal to minus infinity to infinity integral f of x dx, which is equal to -1 to x of 1 by 2 into dx. We are taking the lower limit to be -1 since the probability distribution function exists between -1 and 1 only. Therefore, the cumulative distribution function for x will be equal to x plus 1 by 2, which can be represented as this, as the figure as you can see here. Therefore, the cumulative distribution function for x can be represented as here, where the value will be increasing till the point 1, and again it becomes standard over here. Now, the probability distribution function for y will be equal to e power minus y into u of y. Therefore, as we did in the case of x, the cumulative distribution function for y will be equal to integral -infinity to infinity e power minus y into u of y dy. Since again y is in the range of -1 to 1, it will become 0 to infinity e power minus y dy. Therefore, the cumulative distribution function will be equal to 1 minus e power of minus y. Now, the question asks us to calculate the value of g of x. In order to get the value of g of x, we will be equating f of the cumulative function for x is equal to the cumulative function of y. So from here we know the cumulative function of x, and from here we know the cumulative function of y. If we equate both of them, we will be getting it as 1 minus e power minus y is equal to x plus 1 by 2. Now if we do the solving of this, we will get that y is equal to minus of log base e 1 minus x by 2. Therefore, when x lies between -1 to 1, that is, if x is random between -1 to 1, then y is equal to g of x can be represented as this. That is, it is going to keep increasing from -1 to 1. Therefore, the final values of g of x will be 0 if x is less than 1. That is, if it is less than or equal to 1, the value will be 0. It will be ln of 1 minus x by 2 for the values between if the value of x is between -1 to 1. That is, if the value of x is below -1, it will be 0, or if it is greater than 1, the value will be infinity. But if the value of g of x will be equal to minus ln 1 minus x by 2 if it is between this interval. Therefore, this is the solving of the second question.